them if someone wrote down your test.
Yeah, I mean, mark it wrong. I don't completely fail them.
What? Well, Miss Crowley's a little bit like, she does not like the swears.
I don't like the swears. That is true.
Never know.
Swear.
All right, so before we can talk about side angle side, we need to learn a quick vocabulary word, which is the included angle. You'll hear me talk about the included angle often. And your included angle is the angle that falls between the two sides. So if you were to have congruent sides, the angle that is created from those two sides coming together would be the included angle. Okay? So, before we even move on, just watch up here. This is not on your notes. If I give you the following triangle, I got angle 1, angle 2, and angle 3. Which is the included side of the blue and the red, or the included angle, sorry, of the blue and red sides? Angle 2, good. What's the included angle of the blue and the red sides?
1.
Angle 1. Does everybody see that? What is the included side of the blue and the red sides now?
3.
You don't know.
You don't know yet.
2.
Tricked ya. Thought you knew, but you didn't know. Okay, so included angles. You need to make sure you can recognize what the included angle looks like. All right, so our next postulate we have is the side angle side congruence postulate. Again, this is the only time you have to write it in if-then form, because on your proof, I will allow you to just write SAS congruence. So it says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if two sides and the included angle of one triangle are congruent, two sides and the included angle of another triangle, then the two triangles are congruent. So what would that look like? So maybe I have this side right here congruent to this side over here. And then maybe I have this side to the right congruent to the other side on the right. So in order for my triangles to be congruent, where would the congruent angle need to be? Left, top, or right? Top. Does everybody see that?
What's the top?
That would be where the included congruent angle needs to be for it to be side angle side. If it was down here at the bottom, so let's either on the right or the left, then you would have a case of angle side side. Remember, we do not write bad words on our geometry tests. Okay? So included angle needs to be between the two. Owen.
So if the angle was on one, and I started to explain which was
Top, left, or right?
the left and bottom.
If it was down here, like this.
No, the congruent lines.
If the congruent lines were where?
The left and bottom.
Okay, so if they were on the left and bottom,
Then it would be.
then it would have to be the left angle for the included. Okay? And then if it was on bottom and right, then your included would have to be over here. Right? Okay. All right, so let's see if we can identify it. So determine whether the following triangles are congruent due to side angle side congruence postulate. If so, write a congruent statement. So what I personally like to do is I'll put a little S for my congruent sides, and I'll put a little A for my congruent angle. You ready for this, Sam? So, is this marking representing a congruent side or angle? Side. So I'm going to put a little S here, and then I'm going to match it up with the other side over there. Is this marking an angle or a side? Angle. So I'm going to put a little A, and I'm going to match it up with that A on the other side. Is this marking side or angle? Side, and then side. So that way I know I have two sides and one angle. Is that angle included on the left triangle? Yes. Is it also included on the right triangle? And that's a common trick I like to get you guys on. Is I'll have it work over here, but I will have it different over here, and then you'll say, yep, side angle side. I'll go, hee 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 hee, you didn't get it right because you didn't check both of the triangles. Huh? No, because I like to do that. And I do. I sit there and I go, hee hee hee, as I'm writing it. And I'll think, man, that Sam's going to not get that one. So, does side angles, huh? No, I do not. I do not do that. I'm joking. So, what do we have? Do we have side angle side? Yeah. Yes, so we do. Yes. Write a congruent statement. So, triangle, I'm going to go ABC, is congruent to, what would match up with A on the other side? E, good. And then, yeah, B matches up with, not F, D, and then C matches up with F. Good.
Oh, what the heck?
Okay. Next one, B. I have a set of side here, matching up with the side on the other side. Yeah, so good question. So that I've got two sets of sides. It's not a case of side, 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 because I don't have a third one. But do we have a congruent angle? Yes. Why? Vertical angles are congruent. So we can assume that if I have vertical angles, then my vertical angles will be congruent. So I'm going to put those in there. Mark them with my A. Are the vertical angles the included angles on both sides? Yes, they are. Good. So I'm going to put yes. Triangle ABD is going to be congruent too. So A matches up with, gotta be careful, A is off of the 2 tick marks, so it would be E on the other side, B, and then C. Okay. All right, and then the last one before we do our proofs. Oh, where'd it go? There it is. This is a no, because this is a common case of your bad words, right? Angle, side, side, angle, side, side. So you could say, well, I do have 2 sides and an angle. But where should that angle be for it to be side, angle, side? At the bottom. All the corners are pointy, right? But down here at the bottom. So this would be a case of ASS or SSA. So do not write that for an answer. So we're going to say not possible. All right, Renee.
Do you don't want us to do it just because you don't like the word, or because
Because it's not a theorem,
Okay.
so it's not possible. But I just say that so it's an easy way for you to remember that it's not one of the options. So we're going to have 5 shortcuts. We've got side, 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 angle, side. Angle, side, angle, or angle, side, side is not any of those options. Because you can make non-congruent triangles like that. Okay. All right, so are you ready for proofs? Yeah. Oh, we got one more. Sorry, I forgot about that one. Let's skip that one. Let's not worry about that.
No.
Skip on to the back. Yeah, let's not worry about that one.
Okay.
Okay, 3 proofs. We're skipping that one.
Yeah, I was just looking.
Here we go. So if we set up our T-chart, statements on the left, reasons on the right.
You have to start with your given.
Now what's not so nice about moving away from side, side, side is I'm going to have to list all of my corresponding parts, which is all 6 of them. But as you start getting better at these, maybe you can stop doing that. Me personally, it helps me to just kind of reorganize my thoughts. Huh? Yeah, it does. All right, so I am going to, just for the purpose of our first time going through it, list all 6 of my corresponding matching parts. And I'm pulling those from here. Because if I do that, then I know that whatever I'm putting over here probably is written correctly, and I'm not going to get points taken off on that. So AB matches with CD. Good. BC matches with DA. Good. AC and CA. All right?
Yeah.
Now, I can't just say A matches with C, angle B with D, and angle C with A, due to the fact that I have 2 angles occurring here at A and 2 angles occurring here at C. So when I'm listing my angles, I'm going to have to use all 3 letters, which isn't that hard. It's just a little bit more writing. So if I go angle ABC, angle ABC is congruent to CDA. Someone give me another combination of those 3 letters.
CBA.
CBA is what we just did, just backwards. Try again.
CB congruent to C.
Well, we're doing angles. BCA, I like that idea.
Didn't I just say BCA?
You could have. I think you guys all said something at once.
I think I said BCA.
So BCA would match up with DAC. Good. So it'll be the last one. So right now we have B in the vertex. We've got C in the vertex. So now we need a combo with A in the vertex. CAB would match up with so ACD. Good. All right. So let's see what they give us. What can I check off right away from the given?
CC is congruent to DA.
B, C, and DA. So put a check mark there.
Thank you.
Out of these other ones, which one
That's it.
looks like is my best friend?
A, B, and CD. No,
Why is this one my best friend?
AC and CD.
So what is that?
They're reflective.
That's the reflexive property, right? So let's get that into our proof.
Oh, yeah.
So line 2, AC is congruent to CA, reflexive property. All right, so now let's start marking up our diagram up here. They told us in our given that BC was congruent to DA. Bless you. Do they have those congruent tick marks already shown? Yes and yes. We just said that AC is congruent to CA because of the reflexive property. So let's put double tick marks on that to show that that's congruent to each other. For me to be able to get side, 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 I would need to somehow get AB congruent to CD. In my given, do I talk about midpoint or bisecting?
No.
No, so I can't get another side. So that means I now need to focus to the angles. So I need to somewhere get an angle congruent to each other. More importantly, I'm going to need to get an included angle congruent to each other. So, look up here for 2 quick seconds. 1, 2, 3, 4, 5, 6. Do you see all 6 of those angles? Okay. Out of the bottom triangle, if I just focus here on this triangle I'm making red, if my congruent sides are, I'll make this one be blue, here and here. Which angle out of 4, 5, and 6 would be the included angle? 6. Okay, if we did the same thing up here, the included angle would be what? 3. All right, now let's think about that. Why would 3 and 6 be congruent to each other? Not opposite, use a different word. Alternate. What did we have here in our given? Parallel lines. What do parallel lines get us? Alternate interior angles that are congruent. Whoa.
Whoa, bro.
Isn't that crazy? So I want to somewhere say, if parallel lines, then alternate interior angles are congruent. Well, now what are those alternate interior angles? Which one of these 3 is it listed? I can't just say 3 is congruent to 6 because that's not in the proof. I just put it there. So angle 3 has a vertex of what letter? C, right?
CAB.
So which one of these has a vertex of C?
CAB.
The second one. So BCA should match up with DAC. So that's the one I'm going to put directly across for line 3. So angle BCA is congruent to angle DAC. Now do I have 2 congruent sides and 1 congruent angle?
Oh, shoot.
I've got 1, 2, 3 corresponding parts. Yes? So am I done? Almost. What should be my last line? The prove line. So triangle ABC is congruent to triangle CDA. And what am I going to put on the other side? This is not good. SAS congruence. So make sure that goes after your side, side, side on your blue sheet of paper. So you should have side, side, side congruence. Now we just add it side, angle side congruence. Okay. So do you need to do this each time? Maybe not. Okay. Maybe you can just start putting your markings up here, like if you didn't list them and you were just looking at the diagram. Well, I see the reflexive property right away. So that would have been my first go-to, is get this congruent to each other. You just need to make sure that you have your parts matching up. So notice here in this reflexive property, they're flipped. Then I would have saw, oh, I've got parallel lines. Parallel lines are going to oftentimes get you alternate interior angles that are congruent. And then I would have had side angle side. Okay. All right, let's move to the next one. Going to get your T-chart set up. So statements on the left, reasons on the right. Fill in that given. So we're given that C is the midpoint of BE and AD. All right, so this time around I'm going to try it without listing out all 6 parts. Am I given anything to me right off the bat? Well, any congruencies? No, right? It's not giving me anything that's congruent to each other. Okay. Do I have a reflexive property going on in here at all?
No.
Nope, because they're not sharing a common side. I do have vertical angles. I like that idea. So I would put in my little congruent angles there to show that I have vertical angles. Okay. What does it mean if C is the midpoint of BE? If the point's the midpoint, then it creates, perfect. BC and EC are congruent. If C is the midpoint of AD, then we would get the same thing over there. So AC and DC. So now we got to get that into an actual proof. So remember, on the left-hand side should be your congruent statements. So which one do you want to do first? The vertical angles or the midpoints? Okay, so we're going line segment BC is congruent to line segment EC. Make sure that you have the correct order. BC, EC. BC, EC.
Why does it matter?
Because you need the matching parts to match up.
Oh, but like C is the same thing as AC.
Right. But to get it there, you just want them to be matched up.
You wouldn't even have to.
I personally won't take off points for you, but if you had other teachers, they probably would.
Alright.
Okay. All right. So what am I going to write over here? If midpoint. Good. Then two congruent segments. All right. What do you want to go with next? The angle or the other segments? Yeah, because then I can just do a ditto mark, make my life easy. So if we do line 3, would be AC is congruent to DC. Same thing, if midpoint, then two congruent segments. So now I've got two sets of sides. Okay, there's no way to get the third set of sides. So I'm going to get the vertical angles in there. Now how do we name the vertical angles correctly? Name this angle. ACB would work. Angle ACB would be congruent to, what would the other side be? DCE. I know those letters are tiny. DCE. Can someone give me an if-then statement for that? Should, good. If vertical angles, then congruent. You want to make sure that's on your blue sheet if it's not. Now do I have 3 corresponding congruent parts? Yep. So my last line is going to be the prove line with SAS. So triangle ABC is congruent to triangle DEC. Side, angle, side, congruence. All right, we'll save the perpendicular bisector one for Thursday.